Yeah, I also go back and watch it.
Yes. You consider it's good or no? You
Yes,
say
it's good.
okay. Okay, 31. 31 is x cubic. Entonces, en this question, que there are a lot of similar. We need to find only real zero. Solve the equation. O sea, esa equation, no function. Bueno, because we have equal sign, no? And zero in the right hand side is equation. Entonces, in other words, they want to find the x-intercept of the polynomial. Okay, x-intercept. So they see we have complex solution. No, I don't care. Only real. Well, entonces the fantastic way, remember, don't waste the time. You put in decimals the polynomial as a function. You can see using your eyes the zeros, and you prove me in a piece of paper using scientific division, one by one. And that's it. Okay? Immediately I want to now show you the decimals. Okay, do you see decimals now?
Yes.
Entonces I saw, wow, this is our polynomial, look. Okay, entonces I saw, of course, the polynomial is not given the point, no? The point is not given, no? It's, yeah, but you see, wow, it's -4, and -3, and -1. If you want to see more elegant, you plot the point and put the corresponding labels. Entonces now I need to do at least 2 scientific division, because when you perform one scientific division, you reduce the degree. The original degree is 3. When you are doing the first scientific division, you reduce degree 2. And when you are doing the second scientific division, you reduce to 1, and 1 is a linear, entonces stop. End story. Let's do it. Let's go back. Entonces, this is the idea. Don't waste the time to the another way. No, go directly to the point. Decimals is our frame. Now I go to the whiteboard. Switch whiteboard. I suppose you see whiteboard now. Yes? Okay, let's organize. Let's organize scientific division like that. 1, 8, 19, and 12. Entonces I see in decimal que es -1, -3, and -4. Doesn't matter what do you select. I selected my paper -1. That is a reason que I put here now -1. Pero si you use a -4 or -3, it doesn't change. Bring down 1, multiplication is -1. This is 7. 8 minus 1 is 7. -7 is 12. And -12 is 0. According to the zero factor theorem, the factor x plus 1 belong to the polynomial, or the answer que they want specifically in this question is the 0, que es negativo. See, it's the thing that they want in this example. Now we continue another scientific division. I use a -3. For example, bring down 1, multiplication is -3, combine 4. 4 times -12, 0. Therefore, the factor x plus 3 belongs to the polynomial, que is equivalent to say x equal -3. Good. Now, well, you continue now. Why not? Because in the quotient part, we have x to the 0, x to the 1. Actually, the factor is x plus 4. Entonces x plus 4 es the third factor, que de 0 es negative 1. And that's it. And that's it. Everyone follow me? I suppose that you feel good in the scientific division. You feel good in Desmos. You practice a little bit by yourself. Answer me.
Yes, it's clear.
It's clear, no? Desmos is very, very, very intuitive. And also were more complicated, but Desmos, no. Desmos was created for the student in the high school. The student in high school working perfectly in Desmos. Okay, 32. That's what 31. Any question? No? May I erase the board? You let me know. Erase, yes or no?
Yes.
Good. Okay, 32. 32 is similar. Is x cubed. The problem is that the procedure is similar. However, you can find surprise in the middle of the process because the nature of the zero change. Maybe it's complex, maybe it's real, maybe it's repeated, there's a multiplicity. In this example, 32, I go to Desmos. Yeah, I saw, wow, something is weird. When I go to Desmos, I see, let's go to Desmos. Okay. I suppose you see now this. Yes or no? You see?
Yes.
Okay. 32, when I plot that, look, this is my equation. When I plot that, boom. I don't know what's going on. I saw a line. Actually, it's no line. It's a polynomial. Make it, you make it soon, you see it, wow. But remember, the important thing in this question is the x intercept. So at that point, I can see, oh, it's -7, 0. Okay, let me try to include one extra line here. It's the point. It's the point. Is -7, no? -7, 0. Okay, super. I'm putting label in red color. This is our 0. Entonces, what is the interpretation? The degree of this polynomial is 3. However, I see only one real 0. I suppose that another maybe, I don't know, it's complex. I don't know. I suppose. Remember, the complex you never see in this plane, in this dimension. You never see the complex. It's known 0. Never cross it. Only one. So what should I do? Well, I go to the whiteboard now. Why no? You are doing the scientific division using -7. And let's see what happens. Do you see whiteboard? Okay, entonces, scientific division. 1, 5, -12, and 14. And the 0 que I saw in demo was -7, no? Entonces bring down 1, multiplication is -7, this is -2, multiplication is 14, this is 2, this is -14. 0, good. Therefore the factor x plus 7 is equivalent to, say, x equal -7. Is the only real 0 que have that polynomial. Now what about the rest, professor? What about the remainder? The quotient, sorry. Remainder is this guy. What about the quotient? Well, the quotient is quadratic function. This is x to the 0 power, x to the 1 power, x to the second power. So you're right. Algebraically, this is x squared minus 2x plus 2. No? To prove Okay, not necessary to do. But okay, to make sure to feel much better, you determine the nature of the zeros of this part. You apply discriminant, get b squared minus 4ac. By the way, it's expression inside the radical in the quadratic formula, no? But not necessary, because specific in this question, you need to determine only the real. This is the real. Okay, entonces now b, a is 1, b is negative 2, and c is positive 2. When you evaluate discriminant, is negative 2 squared minus 4 times 1 times 1 times 2. This is positive 4 minus a is negative 4. And when the discriminant is negative, that indicates we have complex solution. That is a reason that you don't see any other real intercept, x-intercept in our decimals. Do you understand very well this idea? You need to be aware of, you need to be aware for that situation. For example, and remember also that the complex is coming by couple 2. So the degree of this polynomial is 3. You have 3 complex. No, impossible. The complex is coming 2, 4, even, right, by couple. Therefore, in this case specific, we have 1 real, 0, and negative 7, so it's real negative, and 2 complex. Okay, I don't care. I don't care because the question says I don't care. And other question says, yes, you need to consider this, pero this, no? Any other question? Everyone follow me?
Yes.
Okay. Let's move on to 33. 33 is 2x squared, no, cube, sorry, minus x squared minus 6x plus 3 equal to 0. Solving this, solving the equation in real number system. Put in decimals. Put in decimals. Wow. I put in decimals. Let me try. I put in decimals. Here. Do you see decimals? Yes or no?
Yes.
Yes. Yeah, I do the graph. Wow. Look at that. Wow. So now the 0 is this number. It's weird. I suppose that when it's weird, it's because it's irrational. We have another. This is nice. This is 0.5, que es 1/2. And this is 0.5. But the 3 0 are real. 2 irrational, 1.73 something, and negative 1.73 something, and 0.5. 0.5 is 1/2. Okay, so now what should I do? Because the irrational, I don't know exactly what is that. But don't worry, because the degree of the polynomial is 3. You are doing one scientific division using the rational, que es 0.5, que es 1/2. And when you obtain one new polynomial after the division, que es degree 2. And degree 2 is super easy by quadratic formula. So this is nothing for us. Compute that. Basically, the strategy in this specific example is then you take the polynomial, doing the scientific division using 1/2, que is rational. The other is crazy, I don't know what is that. Let's see what happened in the second part. O sea, the format for the scientific division is 2, -1, -6, and +3. Entonces 1/2. Pero 1/2 positive or 1/2 negative? Yeah, 1/2 positive, yes. Bring down 2. 2 times 1/2 is 1. 1 minus 1 is 0. 0 times 1/2 is 0. Is -6. Multiplication is -3. Fantastic. I checking that the factor x minus 1/2 belong to the polynomial, que is somehow equivalent to say que the 0 is 1/2 positive. Okay, now we get the quotient. This is x to the 0, this is x to the 1, this is x to the 2. Actually, we have 2x squared minus 6 equal to 0. It's a quadratic equation, but it's super easy to solve, because the only thing you should do is manipulate like a linear equation. You move 6 to the other side, divided by 2, x squared equal 3, apply square root both sides, and x is equal plus or minus radical 3. And this is the famous, this radical 3 is the famous, the decimal approximation 1.73 something 2, I guess so. This is irrational. This is continued forever. Infinity decimal because it's irrational. So what is the final answer? Well, this is the final answer. And this is also the final answer. Actually, we discover, and you see clear in Desmos, that we have three real. One nice rational, and two ugly irrational, pero real. Both are real. No complex. Because complex you never see in the rectangular coordinate system. Because the rectangular coordinate system x and y is real, both axes, y and x. Do you understand the idea, guys? So you need to be aware for different situations. Complex, irrational, rational. I like rational, 1, 2, 3. 1/2, but not always exactly, right? Any question in this problem? No? Okay, entonces I suppose that you have no complaint because we practice a lot of this. I suppose that the students are present here, get good score. Another student, no, but you, yes. Okay, 34 now. 34 is 3x to the cubic power minus 14 x to the second power plus 13 x plus 6 equal to 0. Step number 1, I go to Desmos. 30, we're doing 34, no? 34. Okay. 34, I saw 3. I saw 3 real, 0, 2 positive, and 1 negative. Let's switch into this one. Okay. That's worth 33. No, not 33 anymore. 34. Wow, look at that. We have here 1, 0. Okay, you touch the curve. Okay, you touch the curve. When you touch the curve, you see immediately a gray color point. However, you want to emphasize this idea, you type in here, you open new line inside the question on the same folder. You put 3,0, no? 3,0. Wow. Well, no. I changed the color because blue is not clear. Maybe red is more clear. And you put the label 3,0. What is the other guy? The other guy is 2,0. Okay. I like that. 2,0. Oh, nice. And finally, I saw another. Let me see. This is This is negative 0.3333. How do you know que it's irrational or rational? Well, it's rational. Why? Because when you have decimal approximation and the digit is repeated, 3333333366666 is repeated, is rational. Actually, it is negative 1/3. See the decimal, the digit is different, 3, 4, 5, 7, crazy. They are not following any partner. It's obvious que es irrational. And irrational, the only possibility is computed by the quadratic formula. Entonces es basically negative 1/3, 0, no? 0 because is x in a set. Boom! Okay, super. I include a new one. Okay, let's move on to the whiteboard and perform two-center division using the easy value. No 1/3 is not good. Let me try. Well, okay. Again, we come back to the whiteboard. Okay, the center division in number 34 is this. Is 3, negative 14, positive 13, and 6. Entonces I saw 2, 3, and negative 1/3. I suppose the easy, 2 is easy. Bring down 3, 6, negative 8, negative 16, no? 8 times 2. Now it's negative 3, and negative 3 times 2 is negative 6. Excellent. Therefore, the factor x plus minus 2, sorry, remember in the factor version, it's opposite sign to this, but in the zero version, no, it's the same. Okay, now one more. Easy, no 1/3. 1/3 is horrible. Not horrible, but it's not good. Let me try 3 positive. Bring down 3, 3 times 3 is 9. It's a 1, and 1 times 3 is 3. Wow, fantastic. The factor x minus 3 belongs to the polynomial, que is equivalent to say que the 0 is located at positive 3. And the other is, look, this is x to the 0, and this is x to the 1. In conclusion, this factor is equivalent to say 3x plus 1. You enforce it to be 0 here, and you solve for x, you get negative 1/3. 3x is equal to negative 1 divided by 3. X is equal to negative 1/3. 1/3. See, for example, ask you in the test, the factorization, well, the factorization, this polynomial is open, 3 parentheses, x minus 2, x minus 3, and 3x plus 1. This is like a function, no? See, it's like an equation. Well, we have 3, 0, okay, it's this. Get the answer of that question. Okay. Any question, guys? You are boring to do this? Or is you consider it's enough? Or we continue, practice, and skip because I have another kind of question, no? It's okay. We continue. 35.
I think we can continue.
Okay. Thank you. Boom. Wow. 35 now. This is the beauty of that class. That class is hard. I understand. However, we have 2 hours in each lecture. So you spent 3 hours to make a review. We're reinforcing the concept perfectly. I suppose, in my opinion. Esa es my opinion, no? I respect another opinion, but I suppose que yes. Entonces, 2, no, verify, say 2x cubic minus x squared plus 2x minus 1 equal to 0. Again, I go to decimals. In this case, I don't want to, in order to make a little bit fast this, you trust to me, not necessarily share the screen with the decimal. I don't know si you consider it gets good, entonces I am doing. But the problem is that I have 2 computers. In one computer, I show you the whiteboard like that. In another computer, I see the decimals. Entonces, I see the decimal. Entonces, I detecting. Wow, you have only 1 0. Only 1 0 at x equal 1/2. So 0.5 is 1/2. Okay, no more. So I suppose that the rest is complex, I suppose. Yeah, I suppose. So now let's do standard division. Do you want to see decimal or no? Or we save time? You trust to me, that part is decimals. Opinion. Professor, I want to see or no? Or not necessary? Opinions.
It's not necessary.
Excellent, beautiful. So we have 2, -1, 2, and -1, no? Y I saw in decimal que my good candidate to be 0 is 1/2, positive 1/2. Bring down to multiplication is 1, this is 0, multiplication is 0, this is 2, multiplication is 1 positive. 0 remainder, that means that the factor x minus 1/2 belongs to the polynomial, or the 0 is x equals 1/2. The rest, I have no idea. Let me try. Si es complex or imaginary, I don't care in this question. Si es maybe real, but irrational, so I'm detecting now. This is a moment to detecting this. X to the 0, x to the 1, x to the second, actually is 2x squared, x is missing 2, equal to 0. In factorization 2, x squared plus 1, divided by 2 both sides, so this 2 is completely irrelevant. And this is my factor, no? And my factor is, bueno, solve this equation. Immediately I detecting que es imaginary. Okay? Okay, I don't care in this question. Suppose a more complete idea is suppose what is the factorization of this function? One of the factorization is x minus 1/2, is the factor. Okay, discover que yes, work by zero factor theorem. And we have that part que is 2x squared plus 1. Okay, entonces normally happen que when you have fraction, we have extra factor. And when you put inside this, actually it's 2x minus 1, x squared plus 1. But the only real, guys, is this. The other is imaginary. So actually, this is the factorization of this and the real field. Suppose another kind of question, they say, well, factorization and the complex field. Okay, good. I do. 2x minus 1 is the real part, and you break it down this in two pieces, xx, and the solution is plus and minus I. Plus and minus I. This is the factorization in the complex. In complex, or imaginary complex in general, and this is the factorization in real, in which you can consider it factorization in real, in which you can consider that this expression, this one, is irreducible quadratic. Es a quadratic expression que contain zero complex or imaginary. So leave it like that. In the real field, nobody touched this. And when you are doing intermediate algebra, the professor explained that this kind of question is prime expression. So a squared plus b squared, it's impossible to do anything. It's prime. But it's under the consideration that we are working in the real field. Actually, in the complex field, no. In the complex field, you break it down like that. AA, BB, but BI. BI, YB, whatever, plus or minus. Okay, when you fold this, A times A squared. A times minus IAB plus IAB, que es the multiplication this and this, plus no minus, because plus times minus I squared, B squared. This can always happen. A squared and I squared, I know very well, get negative 1. And negative 1 and another negative 1 become positive. And we come back at the beginning. We did in both directions, guys. Multiplication and factorization. Do you understand this?
Yes.
Yes.
Excellent.
Yes. Yes.
Excellent. That was 30 final. Yeah. I repeat this because we have several situations and you need to be aware of any situation. Okay, let's move on to the 36 now. To say, see, you skip the decimal part, see, we skip the decimal part, we save time and we get advanced faster. Okay. 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 Now, what 36 now? Yeah. 36 is more complicated because it's degree 4. Is x to the 4th power minus 3 x to the cubic power plus 5 x to the 2nd power minus x minus 10 equal to 0. This is my equation. Wow. So I put in decimals. In decimal I can see okay, we have two real zeros at x equal to positive and x equal negative 1. Okay, no matter. Now I prove this algebraically and doing my scientific division using this number, right? And it doesn't matter the order that you are doing the scientific because basically it's a factors, and when you multiply, the order is not important. No? 5, negative 1, and negative 10. I select in my paper 2 first. Bring down 1, multiplication is 2, negative 1, multiplication is negative 2, combine here 3, this is 6, this is 5, and this is 10. Therefore, the factor x minus 2 belongs to the polynomial is equivalent to say that x is equals 2 is a 0. And negative 1 -1 is, let's see, bring down 1, -1, -2, +2, this is 5, -5, 0. The factor x plus 1 also belong to the polynomial x equal -1. I don't see anything more in Desmos. However, the degree of this polynomial is 4. So I suppose that we have two more complex. I suppose, but I need to prove that. Remember, I take the quotient part. This is x to the 0 power, x to the 1 power, x to the 2nd power. Actually, my answer of the several two scientific division is x squared minus 2x plus 5. If you want proof that this is complex or no, you compute the discriminant. Discriminant is b squared minus 4ac. In our specific example, a is 1, b is -2, and c is 5. Entonces es -2 squared minus 4 times 1 times 5. This is positive 4, and this is 20, and this is -16. Yeah, curiosity. It's negative. That means two complex solution. So you want to go beyond that. Not exactly the question. The answer of that question is this. Boom, end the story. 2 and -1. And you verify your scientific. You want to go beyond to this. We computed the quadratic formula, no? The quadratic formula is minus b plus and minus square root b squared minus 4ac divided by 2a. B es -2, entonces 2 plus and minus. I did before the part, que es -16, es square root -16, divided by 2 times 1, que es 2. Actually, this is 2 plus and minus 4i divided by 2. And you split the common denominator, therefore is 1 plus and minus 2i. So 2 divided by 2 is 1, and 4 divided by 2 is 2. This is the two complex guy que I predict in this step, but I found in this step. Suppose, professor, do the factorization of this polynomial. Okay, let's do it. I discovered that the factorization of this polynomial is, so this polynomial, the original, this guy, is equivalent algebraically to this. X minus 2, take that factor, x plus 1, take that factor. Y I suppose que es top. In the real field, we have 1x squared minus 2x plus 5, que I discover que es irreducible quadratic expression. Well. If you want, professor, que factorization in the complex field, okay, let's do it. X minus 2, x plus 1, and you break it down this into x. And the typical format for the factor is x minus, it's a typical format, x minus a. Sometimes it's plus when the a is negative, like in the case of the -1, that is a reason for plus. But in this case, this complex, entonces you copy like that. Another extra parenthesis, 1 plus 2i, minus another extra parenthesis, 1 minus 2i. You can leave it like that, or no, or you write in this way. This is the cosmetic part, the way you prefer present. For example, this is x minus 1 minus 2i, and this is x minus 1 plus 2i. They are equivalent. This and this, complex field, this is real field. Clear or no? That was the question 36. Let me know something, guys.
Would you prefer us to do synthetic division or factorization, or can we do
No,
either?
no, 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 no. I prefer both. Okay, the fantastic way is, Miss, combine together. There are problems. Okay, when you don't know very well that part, in intermediate algebra, you only know factorization. But in my personal opinion, factorization is a little bit weak when you're talking about polynomial, more complicated. That there are polynomials we cannot factorization in the traditional way. It's impossible. However, scientific division is another tool extra que help me to understand. And the combination with the decimal is fantastic. Clear? So no, I do not prefer nothing. I prefer the best option. So, some problem I detecting, no necessarily scientific division, no. By classical factorization, I can do that, no problema. However, another. Mira, by the way, next problem is a typical example. Okay, I never use scientific division. Look, let me show you. Do you understand me the idea or no?
Yes, thank you.
Problem. This is a smart question. This is a question I want to hear. Okay. Erase. For example, next question, get the question. 37, look, is a classical example in which not necessary to do scientific division. No. Because I consider it like a trinomial. No. I use my knowledge of the intermediate algebra. Square root this guy is x squared. And the combination 9 and 4, no, 9 and 4, because 9 multiplication by 4 is 36, and 9 minus 4 somehow give me 5. And what sign? Negative, and positive. Ooh, now I have the dilemma. For example, I need to continue factorization because I saw here clear a difference of a square. Boom. This is a sum. No. In the real field, no. In the complex, yes. Bueno, entonces en the real field hay factorization. Dice la que tu paréntesis es xx 33 plus or minus. And this is the same in the real field. Basically, I don't need to do scientific division. I discover to answer specifically that question, okay, we have two real at x equal minus 3 and at x equal 3. End the story. It's the answer of that question. No necessary scientific division. And the question is, you can do a scientific division? Of course you can. But no necessary. Of course you can. And it's complicated because some terms missing when you are doing the format for the scientific division. You have 1, 0, -5, 0, and -36. It's complicated, right? Because this is x to the 4th power, x to the cube power is missing, x to the 2nd power no, x to the 1 power is missing. Entonces, okay, entonces there are no a recipe. You are using your common sense and imagination, and the combination two tools, factorization and scientific division. Scientific division is another way to factorization. Any question 37? Oh, let me see, 38, I did that? Oh, yes, I did that. 38. 38. Okay, 38. Good. Okay. 38. 38 say. Again, polynomial 4 degree. No, 8. X to the third power plus 16. X to the second plus ax minus 17. Okay. Of course, it's equal to 0, no? It's equation. Because I open Desmos, question 38, I put that. You're detecting that we have two real zero. Add x equal 1 and x equal negative 1. Okay. Entonces is 1, negative 8, 16, 8 and negative 17. I perform standard division using positive 1. 1 times 1 is 1. This is minus 7. Multiplication is minus 7. Is 9. Multiplication is 9. Is 17. 17 multiplies positive 17. 0 remainder. Therefore, the factor x minus 1 belongs to the polynomial, and x equal 1 is the 0 associated with this idea. Now let's do a negative 1. 1 is negative 1, is negative 8, is positive 8, is 17. Wow, and negative 17, good. I like that. 0. And the factor x plus 1 belongs to the polynomial also, que is x equal negative 1. Okay, investigate then the rest, que is x to the 0, x to the 1, x to the second, actually is x squared minus ax plus 17. Entonces I want to prove, for example, que es irreducible quadratic. To prove que es irreducible quadratic, well, you compute discriminant. A is 1, B is negative 8, and C is 17, positive. Entonces negative 8 squared, 64, minus 4, multiplication by 1, multiplication by 17. Okay, entonces this is 64 positive minus 68. I want to multiply 68. That's negative 4. When it's negative, entonces I suppose que it's coming complex. A complex. Super. By the way, why no curiosity? This is out the game, out the question. You apply the quadratic formula, minus b plus or minus square root b squared minus 4ac divided by 12. Who is a? It's 8. Negative a plus or minus square root negative 4. Okay, was I don't need to repeat the operation I did before to discover the nature of the 0, que es complex, divided by 2 times 1. Entonces we have negative a plus or minus square root is 2i divided by 2. Wow, nice. It's negative 4 plus minus I. The 2 complex is negative 4 plus or minus I. This is this. Okay. C1, yeah, the rest is factorization in the real field, factorization, but no, not necessarily, right? So you feel okay, guys? So I propose you skip, or no, 39 and 40. Yes or no? Because it's the same stupid thing, right? See, you want I do. Let me know. So I propose you, in order to save time and dedicate time in another topic, skip 39 and 40. Let me see 39 and 4 apport new ideas or not. Well, yeah, a little bit. What is your opinion? Tell me to do the best way. Because maybe you are boring, no? To do exactly the same. Are you boring or not? No? No? Answer me,
There's
please.
a new idea you can do.
Okay. She proposed me, you can do. Okay, no problem. Okay, 39 and 40. Well, we focus in the idea for the question, no, not necessarily. Si es complete, you do the complete, that's it. Real, only real. Okay, 39 again is a polynomial 4 degree. 2x to the 4th power minus 2x to the 3rd power plus x squared minus 5x 5x minus 10 equal to 0. Okay, entonces immediately I open this one because other hand is crazy. I detecting we have 2 real 0. Add 2 and negative 1. Let me check it just in case. Oh yes. Okay, super. Now detecting this EI proof. Use standard division. 2, negative 2, 1, negative 5, negative 10. I divide by 2. I don't know why I like 2 first. Bring down 2 times 2 is 4. This is 2. This is 2 times 2 is 4. And this is 5. And this is 10. And this is positive 5. And this is positive 10. 0 remainder. I prove algebraically x minus 2 as a factor or x equal positive 2 as 0. And negative 1, I check in negative 1. 2 multiplication is negative 2 is 0. Wow. Times 0 is 5 is negative 5. Is also remainder 0. Therefore, the factor x plus 1 below and x is equal minus 1. Okay, so the rest, I don't know. At least I don't see in this one. The reason is because I suppose it's complex, no? So actually my expression stay in the quotient part is 2x squared. X is missing plus 5. So you try to solving this equation is obvious it's complex, no? You can verify using b squared. You can, of course. B is missing, b is 0, a is 2, c. But in my opinion, it's easy solving the equation, no? 2x squared equal negative 5 divided by 2. X squared is equal minus 5 over 2. And apply square root both sides. And immediately you detecting que es imaginary I, no? Plus or minus. Well, radical 5 over radical 2. Rational I if you want, but it's not totally out the game. Plus or minus I radical 10 divided by 2. Something like that. Clear?
Yes.
Mm-hmm. 40. Let me see 40. 40 is more complicated because 40, the number is bigger number, huge number. Okay, let's see. Okay, and 40, we have that situation. 2x to the 4th power minus 17 x to the cubic power plus 59. You don't be scared. You put in a calculator, no? Any operation, because remember the mathematics is horrible. You change one sign, yeah, you screw up everything. So in Desmo, I can see now on my laptop, we have 2 0, 2 real. Add x equal 1. And x equal 1.5. Or in fraction 3/2. Okay, let's do it. I suppose it's easy. Do first one, it's easy. 2, negative 17, 59, minus 83, and positive 39. And you are doing center division by 1. 2, multiplication by 2, so negative 15, multiplication by negative 15, this is 44, 44, yeah, 44 times 1 is 44, positive 44, this is negative 39, and multiplication is positive 39, negative 39, because negative times positive is negative, 0 remains. Detecting now that the factor x minus 1 belongs to the polynomial, or the 0 is 1. Unfortunately, we have another fraction, but I don't care. I need to do, because when you perform one scientific division, you reduce the degree from 4 to 3. So we have a polynomial degree 3, it's super complicated. There are no formula. They are formula, but it's super complicated. Now you perform the scientific division using 3/2. I prefer fraction. No 1.5. You can do that with 1.5. It's the same, no? But I prefer. Why? Because when you bring down that 2, multiply 2 times 3 over 2 is 3. Minus 12. Multiplication is easier because 12 divided by 2 is 6, times 3 is 18, no? Negative. And this is 26. And 26 divided by 2 is 13, times 3 is 39. Wow, 39 positive, 0 remaining. One more time, is expecting, of course. And the factor x minus 3/2 belongs to the polynomial, or x equals positive 3/2, 1.5. The rest, I suppose, is complex. It's 2x squared minus 12x plus 26. You can see clear like water. Okay, every number in this function is even. So you factorization, the great common factor is 2x squared minus 6x plus 13, no? And this 2 is nice because these 2 combined with this become that factor like a 2x minus 3. Always happen. It's more elegant. You can use it either way. However, this is more elegant. And now, quickly, I need to prove that this is complex, no? Because I don't see any more in decimals. So I suppose that maybe I don't see no necessary that do not exist. Maybe it's too fast, too far. Yeah, I don't see. To say checking. But okay. Compute the discriminant. In our specific example, A is 1, B is negative 6, and C is 13. Okay, S and negative 6 squared is 36 minus 4 multiplication by 1 multiplication by 13. This is 36, and this is 13 times 4 is 12, carry that one 52. That's all because negative. 52 minus 36 is 6, no? Negative 6. It's negative, that's a complex. So you want to determine the complex when you completely finish the quadratic equation. But this is completely out of the game. Any question, guys? Okay, the rest is easy. Look, I propose you the question 41, 42, 43, no important. Forget about this. This is not important. Or skip. Never you see in the test something like that. 44, 45, 46, and 47, yes. But it's easy because basically the only thing that you should do, okay, es the case que you need to find. Okay, entonces 41, 42, 43, no. I delete in my mind. No review, no test. Okay, entonces ahora now let's focus in 44, 44, 45, 46, and 47. Okay, by the way, let me try to, let me see. It's in this page or no? No. I delete everything in the whiteboard. Yeah, upload or download the next page. Okay, what is that? I suppose que es this. Yes. I suppose que es this. Okay, entonces basically, guys, this no. Okay, so we focus in this, and this. Okay, by coincidence, the equation in 44 and 45 is the same. Different interval. And in 46 and 47 is exactly the same, but different interval. That is the reason, and that's my copy in the same line, in the same folder. I want to show you how. It's super easy. I promise in the test I put one question like that. All right? Let's do it. Moving on to Desmos now. And we focus in. Okay, and the equation, we are doing the equation 44 and 45. Okay, look, and this might put 44 and 45. Look, 44 and 45. Okay, look, I copy both. 44 is, okay, let me delete everything. Or no delete, enable. This is 44. Este is polynomial. Okay, suppose. To explain clear. Do you see this more, right? Yes or no? Do you see or no?
Yes.
Okay. Look, let me explain one thing. I create one new line. I just copy the function without restrictions. Control C, Control V. This is my polynomial. This is the graph of my polynomial, exactly the same way I doing before. But I want to see one specific piece of this graph, que es in between -3 and -2. Okay, maybe I use a different color. Let me change the color, black. Oh no. Well, no, it's okay. But much better to see more clear is you delete. You take the piece of curve in between -3 and -2. Yeah, I see here clear the 0. I click in the graph. I put on the gray point. Yes, -2.618 is the answer. Do you understand very well?
Yes.
This is but the problem that we are doing before is nice. It's a problem that I create for you. Okay, normally you can do scientific division easy because it's -1, +1, 2 is a whole number or fraction, 3/2, 1/2. This is easy, but when there is irrational number, it's hard. Entonces, the only possibility we have is this, graphically. Or in sophisticated graphic calculator. Pero no, it's too expensive, however, that's more free. Okay? This is 44, no? And 45 is similar in the same curve, in the same polynomial. Pero I change the interval x from -1 to 0. Okay, that piece I click here and the answer is negative 0.38. Boom. Finalized. Super good. Any question? You understand very well the organization in Desmos?
Yes.
Awesome. Okay. And 47 and 46 and 47 similar. Very, very similar. Look. Okay, this is, wait. Let me open. Okay, I copy, I put enter to open new line. I copy the polynomial, Control C, Control V, paste. Okay, this is my famous polynomial, right? Degree 4. Okay, of course, degree 4. The end behavior is right up, left up, no? And in the middle you have a mess. I don't know. Okay, so now in order to visualize, for example, the first part, is when there's in between -3 and -2, is this part. And you touch the curve and you go on the gray color point, is -2.236, okay, the option C. Likewise, you want to determine another interval, click here. Okay, but on this interval we have 3 gray points. Well, the reason is que en 2 is also solution, but 2 no, because 2 is not included inside this interval. Okay, is actually, I could be here wrong. It's less than or equal. No, it's less than, not equal, and the original problem. But I can fix it now if you want. But this doesn't change the idea. A ver, delete, less than, done. Do you see? Entonces now when you click here, oh, you see only 2. Bueno, no, pero the gray point in Desmo is not necessarily X in a set or Y in a set. Es the point que Desmo consider important. Entonces this is a local minimum. And Desmo consider important. What important is this? Que es positive 2.236, que es el solution. Super. Yes or no? Okay.
Yes.
Let's move on to another kind of problem. No Desmo anymore for a moment. Let's move on to the whiteboard. Excellent. Whiteboard. Excellent. Boom. Okay, they want to find if a polynomial for x with real coefficients having the given degree and zeros. In the question number 48, the zero, degree is 3. This is a requirement. You generate, using your imagination, equation for the one polynomial que satisfy that condition, degree 3. Entonces, I know que si degree is 3, we have three zeros. Consider a repetition, complex, and real. And the zero que is given is -2 and 3 plus I. Okay, I appreciate so much that help, but that help is not enough. Because I know that when you have complex, the complex is coming by pair of conjugate. And the other guy is 3 minus I. Okay? Okay. Now, I create 3 factors using that numbers. Multiplication, this is completely opposite operation. And the other operation, we are doing factorization, using scientific division or classical factorization. Now, no. Now we use multiplication. Pero entonces I organize the multiplication in this way. You multiply the complex first. So you multiply the complex first. How? My recommendation is open the bracket. You put x minus 3 plus I times x minus 3 minus I. After, I don't forget this factor, no? Que es x plus 2. But this is after. What is the reason? The reason is, so you are doing crazy. You can do it either way. You create this factor and multiplication this factor times this factor, but this is crazy because when you combine a real and complex, it's complex, coefficients is complex. This is not wrong, but it's complicated. However, when you multiply complex and complex, doesn't the complex undo each other. So I take advantage this side. What? So you foil now, foil. Okay, entonces es x times x squared. X times this is minus 3 minus I x minus 3 plus I times x is minus again 3 plus I x, and negative and negative together is positive 3 plus I 3 minus I. Okay, now I dedicate now, this is the order I have in my mind, to do the operation of this. When you multiply two complex numbers and they are conjugate each other, the answer is real. The answer definitely is real. So you copy in one corner of the piece of paper 3 plus I times 3 minus I. Yeah, I know the shortcut to do this in 1 second. 1 second. You multiply 3 times 3 gets 9. And 1 times 1 is 1. And plus the answer is 10. The students that don't know this shortcut, no problema. You are doing like a kindergarten guy, que you foil again this. And you multiply 3 times 3 is 3, is 9, sorry. 3 times I is minus 3i. I times 3 is plus 3i. And this is negative I squared. So I times negative I is negative I squared. Always happen que this is cancelled. And you know que I squared is negative 1, entonces es 9 plus 1. Y the answer is 10. And the answer of this part is 10. Real. Okay, entonces we come back. In the second line, I copy x squared minus 3x. Okay, you distribute it, no? Plus ix minus 3x again, minus ix, plus 10. Plus 10. Entonces I can see que the imaginary part is cancelled. This is the beauty. That is the reason que the complex is coming by pair, because on those each other the multiplication. So far we have x squared minus 6. So I come from 6, negative 3 and negative 3 together, plus 10. Oh, that's it. No, Professor, you forgot x plus 2. Okay, now this is piece of cake. This is foil, but more complicated because we have 6 possibilities, no? 3 trinomial, 2 binomial. This is x cubic. Get the multiplication, this and this. Now the multiplication. In my mind, the organization is you take the first and multiply by the second 2. This is plus 2x squared. And you take now this and multiplication this is minus 6x squared again. And this. Okay, so minus 12 x. Finally, plus 10x plus 20. And the rest is just combined like term. X cubed stay alone. This and this together is negative 4. And this together is negative 2 plus 20. In the story, this is my final answer. This is a polynomial que I built que satisfy this requirement. Degree 3, negative 2, and 2 complex 3i, and of course the conjugate associated with this. Super clear? There are many ways to do. However, I explain the way I consider it easy. Got it?
Yes.
Absolutely. 49 is similar. In 49, let me read that. 49. Okay, degree 4. So you have 0 is x minus 1. So we have factor. We have a factor que is x plus 1. One more, get 2, x minus 2. I separate the real part, apport 2 factors. And the imaginary part is 1 minus 2i, 1 minus 2i. Entonces, x minus 1 minus 2i. And the conjugate associated with this is x minus 1 plus 2i. It's okay? Is it okay?
Yes. Yes.
Now foil. Foil is x squared minus 1 plus 2i x minus again 1 minus 2i x plus, oh, I like the shortcut. The shortcut is 2 times 2 is 4, 1 times 1 is 5. Yes or no? Yes or no? Do you understand very well the shortcut? Honestly, say yes or no. Do you understand? Say again.
Can you go over it again?
Over again. Okay, over again. See, one can go over again. Basically, it means in that moment, the thing that we are doing is multiplication this. Yeah, I know in 5 seconds, get 5. Why? You multiply this time this, and this time that. 1 times 1 is 1, and 2 times 2 is 4. I don't care this side, I don't care this negative. I guarantee you can always work. However, if you don't remember, no problem, I understand. And you are doing like a kindergarten guy, que is FOIL. 1 times 1 is 1, 1 times 2i is 2i, negative 2i times 1 is minus 2i, and negative 4i squared. It's a cancel as always, 1, and I know that I squared is negative 1, this is plus 4. F5. It's easy or it's hard? It's easy or it's hard?
Yes. Thank you.
Entonces, my recommendation is do by the shortcut. Entonces, now you apply distributive property here, x squared, this is minus x, minus 2ix, minus x again, plus 2ix, plus 5. Okay, now it is cancelled. This is expecting. Okay, now we have x squared minus 2x plus 5. Beautiful. Now multiplication by the multiplication again. This and this. Well, I suppose I do need to explain this, no? It's too long. So I recommend do first this multiplication. And now finally trinomial. So you have 2 binomial multiplication, get 1 trinomial, another trinomial together, give me a possibility. This is long, I know, but it's completely easy. You know, in mathematics sometimes happen que the thing is easy, pero it's too long. Entonces you waste the time. That is the reason I highly recommend using software. So there are several software in the market, free, totally free in internet, like Symbol Lab, Wolfram Alpha, can help you to improve your algebra. You put here everything, blah, blah, and this multiply and condensing. Entonces maybe it's easy, I understand. However, when it's long, we make a mistake. Why? Because we are human, and you change accidentally one sign, and that's it. This is the answer. Okay? Do you understand the idea for the 48, 49? So you consider que 50 and 51 I skip because that's the same stupid thing, right?
Yes.
So let's move on to the 52. 52. No. Si son students say, Professor, no, I want that you are doing the 50 or 51, but it's the same. It's the same. Let's go to the last page. And the last page is similar, but bring me a new situation. Okay, last page. Okay, there you go, 52. This is easy, I guess so. Because it's x cubed minus x squared plus 16x minus 16. Wow, this is a classical example in which is super easy by classical factorization. Because you have to couple, for example, the red one and the blue one. And you apply factorization by grouping, no? What is the GCF in the red couple? It's x squared. And we have x minus 1. And what is the GCF? What the hell? Okay. And what is the GCF? Well, this was x squared. X minus 1. What is the GCF in the blue couple? 16. Plus 16, like so. And you see, wow, fantastic. I like that x minus 1 is a common factor. I factor out one more time. And we have x squared plus 16. Okay, now in this moment, everyone realize que es irreducible quadratic. So see, you, for example, are working in the factorization of the real field, you stop. Don't do anymore. However, this say, find all zero of the function and write the polynomial as a product of the linear factor. What means that? That means que I want no reducible quadratic. Quadratic is degree 2. No, linear is degree 1. So you continue factorization in the complex field and you consider it like a 2 parentheses, square root this guy is x, square root this guy is 4, but now it's no 4, sino 4i. 4i, plus or minus, end the story. This is a factorization. They want, they want this. Okay. Do you follow me? And by the way, is the option A now? Yes. The option. Do you understand very well or no? Yes or no?
Yes.
Okay, 52. 52. No, 53 now. 53 now. 53 is x cubed plus 8, no, 11. 11 x squared plus 36 x plus 26, no? Yes. Well, in this case, it's a little bit different. This is 53, no? 53. It's not obvious, it's not clear. It's confusing, at least for me. Entonces es, immediately I put in decimals. Y when I put it in decimals, I detecting that we have one real zero at x equal -1. -1? Yes, -1. Okay, okay. Entonces I take advantage of this fact. And I perform the standard division for the real. 1, 11, 36, 26. Here I put -1 here. Bring down 1. This is -1. This is 10. This is -10. This is 26. This is -26. Zero remainder. I prove it for sure x plus 1 belong to the polynomial factorization. And also the verification of decimal, que -1 is 0. Now, I don't see any more real. I suppose that this is a reducible quadratic, so x squared plus 10x plus 26 is irreducible quadratic. You know the way. You compare the discriminant. B squared minus 4ac. Okay, in our specific, A is 1, B is 10, and C is 26. Okay, let's do it. It's 10 squared is 100, minus 4 multiplication by 1 multiplication by 26. So actually it's 100 minus 26 times 4. I suppose it's bigger than 100, of course. 26 times 4 is 104. And the answer is -4. See, it's negative, it's complex for sure. But I need to detect it. Now the last part of this problem, no, it's complex, and that's it. No. I need to determine the factorization in the complex field. So the formula is minus b plus or minus square root d, right? Actually, so you want to put d here, no b squared. It's a b to a. So es -10 plus or minus square root -4 divided by 2, because a is 1. Then -10 plus or minus 2i divided by 2, is -5 plus or minus I. Super. And the factorization for the complex part would be x minus -5 plus I times x minus -5 minus I. Or either way, I prefer that way, but more elegant, in my opinion, is plus 5 minus I, x plus 5 plus I. Plus I. Okay, entonces, what is the final answer? What is the super fantastic factorization of this? Remember, degree 3, I detecting one real, que es x plus 1. And this is the total answer of the factorization. Well, I suppose que es B, no? Let me see, I am sure. B o A? B o A? A. But I'm not sure. You let me know. You see much better. You're young. Okay, es plus 5 plus I plus 5 minus SA. I guess so. You let me know if I make a mistake. Any question? Do you follow me? Complicated or easy?
All good.
All good. All good. 54, 54, 54, 54, 54. Now 54. Now 54. Okay, now 54. 54 is x cubed. Oh, nice, because degree 3 is easier. Plus 8x squared plus 24. 24x, no? Yes, I copied wrong in my paper. 24x. Let me fix that. 24x plus 24. Plus 24. I quickly inspect, checking. Because you see, it's possible to do something by regular factorization. I suppose no. Because 24 is common factor in the last couple, but we have nothing here, como x squared. So there are no coincidences, because the beauty of the factorization by group is when you select the couple and you find the GCF individually in each couple, and the next step, the factor should be identical. See, it's different? No. Therefore, in the 54 example, I detecting that maybe we have one zero real. Yes, at negative 2. Using decimals, I detecting we have only one real at x equal, let me check again, negative 2. That's it. So the factor is x plus 2. So I extract this factor for the polynomial using the idea for the decimals. I detecting the zeros. So I discover x plus 2 belong to the factors polynomial. So now to reduce the degree to the second degree, I use second division one more time. 1a 24 24. And minus 2 here. Remember, the number you put here in the second division is exactly the same of the zero, not the factor. The factor is opposite. In down 1, negative 2, 6, negative 12, positive 12, negative 24, 0. Super. This factor belongs. Now I focus it in the quotient part, x to the 0, x to the 1, x to the second, x to the second, plus 6x plus 12. I suppose that I don't see any more in decimal, so I suppose it's complex that part. 1, b is 6, and c is 12. Discriminant, b squared minus 4ac is 6 squared minus 4 times 1 times 12. This is 36, and this is 48. And this is negative 12, no? Yeah. Okay, entonces negative confirmation complex. Okay, now the quadratic formula minus b plus or minus radical d divided by 2a. Minus 6 plus or minus square root negative 12 divided by 2. Well, 12 is 4 and 3, and square root 12 is square root 4, this is 2 radical 3. Actually, we have minus 6 plus or minus 2 radical 3 I. Don't forget the I part, it's important. 2I radical 3 divided by 2. You split the common denominator, so we have minus 3 plus and minus I radical 3. Beautiful, beautiful. Entonces, the rest is the cosmetic part. Okay, the cosmetic part is you put the factors. Remember the first factor I discovered was x plus 2. And the other factor is x plus 3 minus I radical 3. And other is x plus 3 again plus I radical 3. Got it? That was 54. That was 54. Okay, 54. Elegant. Guy, are you boring? What do you think? Is enough? We are ready to... We are doing 55. 55 is important. 56 and 57. End the story, right? This is the last one. Okay, 55 is important. 55 is important. Let me try 55. Okay. 55 is x to the 4th power minus plus, sorry, 34 x to the 2nd power plus 2025. Factorization in the complex field is. Wow, 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 wow. I have no idea. I'm totally lost. So now, I don't know. Say need to do scientific division or regular factorization. I do the graph. This is 55. 55. When I do the graph of the 55, I don't see known real zero. Wow, to say I cannot do anything of the scientific division, no? Impossible. Now I take advantage que trinomial. Entonces the factorization is, you know, x squared here, x squared here. And so I need to find a combination that maybe it's a little bit hard. Two numbers can multiply each other, give me 225. Two numbers can multiply each other, give me 225. And somehow, when you're adding or subtracting, plus or minus, give me 34. And the combination is 25 and 9. Let me check it. 25 times 9 is 225. And 25 plus 9 is 34. You try. See, you cannot. Well, you apply the quadratic formula. And you get the answer. Let's try. Let's try. Okay, suppose that I don't see that. No. It's not clear for me. Or I'm consuming too much time doing that. Well, so you consider this like a quadratic, que es, bueno, x squared plus 34x squared plus 225. And you see that A is 1, B is 34, and C is 225. And you try. It's a negative 34 quadratic equation, plus or minus square root 34 squared minus 4 multiplication by 1 multiplication by 225 and everything divided by 2. Let's see, you don't know guessing that. 34 squared is, okay, 34 squared is 1,156. Now 225 times 4 is 900. Something's weird. All right, let me see. I'm doing something wrong. Everything is positive, right? 900. Okay. Entonces, 1156 minus 900 is 256. Okay. 256. I like that because 256 is perfect square number. And the square root 256 is 16. Okay, beautiful. Then we have negative 34 plus or minus 16 divided by 2. You separate into pieces, negative 34 plus 16 divided by 2, and negative 34 minus 16 divided by 2. Okay. 34 and 16 subtraction is 18. Negative 18 divided by 2 is negative 9. And 34 plus 16 is 50. But actually it's negative 50 divided by 2 is 25, negative 25. And this is our combination. Our combination is 9 and 25. But actually, when we are doing the factorization, you put 9 and 25, or 25 times 9 either way. And the sign is obvious que es positive. Okay? Because remember the sketch of the factor is minus, but double minus becomes positive. However, it's logical because in our original trinomial, everything is positive. It's positive. And this is the factorization. Wow! So what do you think now? You think that this is irreducible quadratic complex, irreducible quadratic complex. And the factorization this is in the complex field, of course. XX, phi I, plus or minus, 3I, plus or minus. End of story. Do you see that? More clear or no? Well, entonces I propose you stop because the rest, o sea, 56 and 57 is the same. Igual I do, pero no. I suppose que no es necesario. You let me know si es necesario yes o no, professor. Come on. It's okay or no? We finish. We continue. Are you sleeping now? I suppose. Let me see your face. Opinion, guy. What should I do? Hey, nobody answer me.
You can do 56.
56. So she proposed me do at least 56. Okay, let's do it. Okay, 56 now. 56. I detecting in 56 because 56 is more complicated, not complicated, long, because of degree 4. X to the 4th power plus 2x to the cubed power plus 6 x to the 2nd power plus 18x minus 27. So immediately I put in decimals to understand a little bit. 56. Y I detecting 2 real 0. 2 real. At x equal 1 and x equal minus 3. Therefore, I need to perform 2 synthetic division. 1, 2, 6, 18, negative 27. I'm doing 1 first, because I consider it easier. 1 times 1 is 1, is 3. And 9, and 9, 27. 27 positive, 0 remain. The factor is the factor, x minus 1. Now negative 3. Okay, negative 3 is bring down 1, negative 3, 0. This is 0, this is 9, this is negative 27. Wow, fantastic. The second factor real is x minus 3. Well, I know, or I knew. However, I prove now. I am more comfortable, more. And the rest is piece of cake. The rest is irreducible quadratic complex, que es x to the 0, x to the 1, and x to the 2nd. Wow, but this is easy because I know very well that the factorization of this is xx 3i plus or minus. But the factorization for this question is this factor times this factor times this factor times this factor. In this case, we are using only linear. The objective of that question is linear factor. Linear factor means degree 1. No acceptable quadratic irreducible. Sorry, it's complex, but okay, you separate complex. Clear or no? Okay, entonces now, guys, I did my best. I don't know. You need to do your best now, okay? Remember, due date for everything. This is next Tuesday. Next Tuesday, we start new chapter. By the way, super interesting. No big deal. Easy, relatively easy. Okay?
Professor,
Please, go ahead.
it's due at midnight on Tuesday.
What do you say?
Everything's due at midnight on Tuesday?
Yeah. So you need some extension. Remember, guys, any particular situation, for a student, you email me. No here. Here is lecture, is a mathematics. You communicate with me. Communication is extremely important. So you have issue, some problem, you communicate, entonces we negotiate solutions. Okay? Any other problem? Are you clear?
Yes.
What you think you should do? Okay, thank you. Bye.